Hey everyone, in this video we're going to be looking at the big ideas for section 9.1. So let's get started. The first thing we're going to look at are the conditions for a one sample t interval for mu. Remember, this is what we're looking at is a one sample t interval for mu. So the conditions are pretty much the same as the conditions we are familiar with. We've got the randomization condition, and that we check that one so that our sample represents the population. We've got our 10% condition, and our sample needs to be less than 10% of the population size. And the reason we check that is so that the standard deviation formula will work for us. And then we have the large enough condition. And we talked about this in the lesson itself. And there are three things that we need to check, or three things that we could check. So make sure that you watch the lesson video to get those three things down. Very quickly, we would say either we know the population is normally distributed, and therefore the sampling distribution will be normally distributed. And it doesn't matter what the sample size is. Or the second thing is the central limit theorem tells us that as long as our sample size is at least 30, our sampling distribution will be normal, and therefore our sample size is large enough. And then the third thing that we can do, if we don't know anything about the population and the sample size is less than 30, then we can graph the data that we have. And if the sample does not show any outliers or any obvious or extreme skewness, then we can assume that the population is normal, and therefore our sampling distribution will be approximately normal as well. The second thing we're going to look at in the big ideas here are the critical values. So when we were working with proportions, our critical value was z star. But when we are working with means, our critical value is no longer z star, it is t star. So we use t star for our inference for means. Now, a couple of things that we need to know. We need to know the degrees of freedom. So for a one sample t interval for mu, the degrees of freedom is equal to n minus 1, or our sample size minus 1. Now this value of t star, we're going to get from table B. Now there is a way that you can find it with your calculator, but we're going to use our table along with the degrees of freedom and our confidence level to find that t star critical value. And remember, we will always round down if our degrees of freedom is not on the table. So if for some reason you look at your table and the degrees of freedom isn't there, we're going to round down to the nearest degrees of freedom that is on the table to get our critical value t star. The four-step process is pretty much the same as what we had for proportions, but there are just a few changes. So let's quickly go over those changes. When we state things, we need to remember that we are stating mu, which is the true mean. So we don't want to use the letter P. Some of you have gotten into the habit of using the letter P right here for parameter. P does not stand for parameter. P stands for population proportion. So whenever you're working with proportions, you're okay to use that P as long as it's a single proportion. But now we need to say mu is equal to the true mean of whatever the context is. When we go through our plan, the name of the procedure is different. So instead of a one sample Z interval for a proportion P, it's a one sample T interval for mu. And it's important to use mu, a one sample T interval for mu. So make sure that you use T and make sure that you're using mu. Then the only condition that is different is our large enough condition. We've already talked about that a little bit. So there's the reasons why, or there are the things that you check for the large enough condition. And then we get to the do. Well, in the do, the biggest difference is the formula. So no longer are we using p hat and z, we are using x bar for our sample mean or our point estimate, t star for the critical value, and then the standard deviation of x over the square root of our sample size for the standard error. But here's the formula. And then for the conclusions, really nothing changes. Everything is stated the same way. I am 95% confident, that the interval from blank to blank. So there are the big ideas for and the changes for our four-step process. Now we've got a little bit more to talk about in the big ideas, and that is finding sample size. Sometimes you're going to be asked to find a sample size and you are given the confidence interval. So if you know the margin of error and you know the confidence level, then what you're going to do is use this formula. Take the margin of error and set it equal to t star over the standard deviation of x over the square root of your sample size. And then it just becomes algebra. If you plug in the margin of error and you plug in the standard deviation and you plug in the critical value, then you should be able to solve for n. Some of you had a little bit of trouble with that, and I find that this particular type of question, some people have trouble with it, but it's not because they can't do the algebra, it's because they don't think about setting up their formula using the margin of error. So hopefully this will help you understand that a little bit better. Plug in everything that you know and then solve for n. Now the problem is, in order to find in order to find T star, we need to know the degrees of freedom. Well, in order to know the degrees of freedom, which is n minus 1, you would know what the sample size was. So in most cases, if you do not know T star, and in most cases you won't know T star, then what you're going to do is you're going to use Z star for that particular confidence level in place of T star because it is unknown. And then you would solve for N, and that would give you the approximate sample size that's being asked. So that's all the big ideas for this particular section. Hopefully this helps you understand a little bit better, and hopefully you have a great day.